The title is Carriage Evacuation in Local Public Rail Transportation Systems in Case of Fire, Experiments, Finding, and Human Behavior.
Thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. I'm going to talk a little about carriage evacuation in case of fire. And as it seems, I'm doing a introduction. The last one before a big break. So, what we will have about human evacuation and evacuation, when we come to this not big representative group of evacuation of these heavy people. Have you ever thought about yourself how you are going to evacuate and leave a train in the case of a fire? Most of us use public transportation systems, and most of you think about evacuation and the problems with it. So, today I'm going to show you some of the findings of our experiments. I'll start with the content. I started with a few research questions and explain the experiments, the evacuation experiments, and finish with the results and the findings. So now, let's jump into it. 15 minutes are quite short. The aim of our studies was to examine the evacuation from high floor trains on a train, both to the unlimited lateral space, to the open space, and to the limited lateral space. The other thing was wanted to examine the movement along a limited lateral space, like it would be in a narrow pathway, or for example, a tunnel situation. The focus of these were on the human behavior and the flow rates. Now, if we start with experimental work, there were different spaces where the participants could evacuate to or move. On the one hand, we had this open space, there were no obstructions, no handlings, like in this unlimited open space. The second was limited lateral space, like I said before, in the narrow pathway. And it was also possible for the participants to move inside the trains. We used two types of vehicles. On the one hand, we had a commuter train, the one on top. The second one was a metro train. For both trains were stationary, so they were on a safe place. And the evacuation always took place only on one side of the trains. Now, if we consider these two different spaces that the participants could evacuate to a little bit more in detail, I would like to start with this unlimited lateral space, the open. You have different heights to step down for the participants. In the community, we had 0.65 centimeters, but the participants had to step down from inside the train to the surrounding ground. And the metro train was higher, it was about 1 meter. This picture here shows the metro train. As said before, we had the evacuation only to one side of the train. In the open, two hard surface grounds with no trails and no rails. And the participants could move away. They won't stop with any obstructions or any handrails, just could move very free. The big difference here to the unlimited lateral space, in most of the tunnels you have quite a long way until you reach a safe pace, 300 meters depending on the sign rules. Sometimes it's often not possible to move in both directions of the trains. So we made evacuation tries where the participants could move on one side and only to one direction. We conducted these experiments in the open for security reasons, but tried to get the real geometry what it would be in a tunnel. In the tunnel we have a lateral space of about 0.75 centimeters, and there's a handrail at the height of 1 meter, but it comes into the security space 10 centimeters. So we have a free lateral space, also in this situation for the experiments of a free lateral space of only 0.65 meters. We have also this handrail, like would be in the tunnel, and we have a height